Welcome to Study Loop.
Okay, so in this question, we want to show that if the cardinality of a set is M, then there's a one-to-one correspondence between this and 1 to blah, blah, blah to M. So this is the first thing that we'll prove. So to prove this, what we'll do is, because S has M elements, we can write S as Si or S1, S2, blah, 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 and Sm. We then define a function that takes the element I and returns I back. So that is, f then maps us from the set S to 1 to blah, blah, blah to M. So then we need to prove that this function is both onto and one-to-one, and then we can assume that there's a one-to-one correspondence between this. So first, to prove that it's one-to-one, so if we have f of s of I is equal to f of s of j, then this implies that I is equal to j by definition of our function. So therefore, f is 1 to 1. Now to prove that it's onto, for every I in the set of 1 to blah, 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 m, there exists s sub I such that f of s sub I is equal to I. So therefore, f is onto. Since it is both onto and one-to-one, f is a one-to-one correspondence, one-to-one correspondence between the sets S and 1 to blah, blah, blah to M, which therefore implies that there is a one-to-one correspondence between S and 1 to blah, blah, blah to M. Now, for the next part, if we have S of S is equal to T is equal to M, then we want to prove that there is a one-to-one correspondence between S and T. So first, what we'll do is we'll define our function, which maps S to T. Because these have cardinality M, we can write S as a set of S1, S2, blah, 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 to Sm. And we'll also write T as T1, T2, blah, 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 Tn. Then within this function, we write it as S sub I is equal to T sub I. Now it's our turn to prove that this is both one-to-one and onto. So first, one-to-one, if f of s sub I is equal to f of s sub j, then we want to prove that t sub I is equal to t sub j. So by the definition of the function, we have t sub I is equal to t sub j. Since these elements are distinct, we must have I is equal to j, because t sub I are distinct. So therefore it implies that the inputs s sub I is equal to s sub j, which is s sub I. So therefore f is 1 to 1. Then we want to prove that it's onto. So for every t sub I in T, there exists s sub I in S such that f of s sub I is equal to t sub I by definition. So therefore, f is onto. Since f is both onto and one-to-one, there is f is a one-to-one correspondence between S and T. So therefore, there exists a one-to-one correspondence between S and T.